particular, we're going to talk about equivalent trigonometric expressions. How to understand what it means. In order to get an idea how it works, let's recall graphs of sine and cosine functions. This is our coordinate axis. On the coordinate axis, we're going to position like this is y, this is x value, this is 0, let's say this is 1, this is -1. And let's see. Oh, sorry, it's not 1 and -1. No, 1 is gonna be here in y-axis, and -1 is gonna be on y-axis as well. While here, we're gonna have a radian measures for the angle for x value, because our cosine of x, the sine of x, dependent on x as a independent variable. So 0 pi over 2 and pi. Negative pi over 2 and pi. So, negative pi. If we were to sketch the cosine function, we remember that 0 cosine equals 1. I'm going to use green color for cosine function. At pi over 2, cosine value equals 0. So our graph would look as follows. And repetitively repeating this pattern. Okay, this is the cosine function, cosine. Now, what we can say about sine function? Sine function equals 0 at 0, and it equals 1 at 5 pi over 2, right? And it's negative at negative pi over 2. So here are 3 points. Let's join them with nice smooth curve. Then sine turns into 0 again in pi and repeats the cycle. What can you tell about these two curves? Basically, is that they're both are the same curve, but with an offset along the x-axis. Can you see that? If I take, look, if I take my graph for sine function, which is the red one, and I move it to the left by pi over 2 units, look, they coincide. They're same. Is that clear? So basically, we have an offset between sine and cosine function equal to pi over 2. This is the offset. See, cosine equals 1 at 0, and sine equals 1 at pi over 2. And same for every other point. You see? Pi over 2. Pi over 2. Is that clear, guys? Please give me your feedback. Is it clear why sine and cosine functions have an offset pi over 2 between each other? Great. Thank you for your feedback. Now, let's move on. Within a right-angled triangle, we can show equivalent expressions as follows. For example, let's say here is the corner x, right? X. It's pi over 2. So basically, let's say sine x is opposing side divided by hypotenuse. So a over b. But it's also going to be equivalent to this angle that we don't know, cosine of that unknown angle. Is that correct? Because cosine is the adjacent side against the opposing one. And now we can see there is a sine function, and there is also must be an equivalent cosine function to it. How do we define what angle is here? Let's look at the right angle triangle and remember how to find angles in here. So the unknown angle would be equal to 180 minus pi over 2 and minus x. Is that correct? Because total degrees are 180. We know x and pi over 2. But how else can we write this? 180 is also pi, so it should be equal to pi over 2 minus x. So we substitute this into brackets, and what we get that sine x is equivalent to pi over 2 cosine. Sine x is equivalent to pi over 2 minus x. Because you ask how is 180 is pi? Because pi 180 is expression of an angle in degrees, and pi over 2 is expression of an angle in radians. I convert degrees to radians in order to perform subtraction. And if you look on the position of angles, as we did it in the previous class, here is 0, pi over 2 is 90 degrees, and pi is 180 degrees, right? But there is also another way to convert degrees to radians, as we spoken in the very first class. It would be 180 times pi over 180, which gives us pi. So 180 equals to pi. Okay? I cannot subtract 180 minus pi over 2. I have to convert one of them to radians or degrees. But for me, for our purpose, it's convenient to use radians as soon as we do that all the past classes. And it's the right way to work with sine and cosine function. So here it is. Here's the equivalence. Sine x equivalent to cosine pi over 2 minus x. Is that clear? Is that clear, guys? Is that clear? My reasoning about equivalent trigonometric expressions within a right triangle? Anybody? Thank you, Safa, but everybody else? Any questions up to this point? Okay, thank you, Hala. Well, let's move on. Here, if you look on the unit circle, as shown, we're gonna realize equivalent trigonometric expressions due to shift of pi over 2. You see that here's the first point with an with angle of that is equivalent to x that is less than 90 degrees, and second angle which is pi over 2 more clockwise. And if you look here, basically sine value in this point will be equivalent to cosine value in this point. Those are equivalent trigonometric expressions. So basically what they say us is that cosine x in this case equals to sine x plus pi over 2. Is it clear? This is equivalent trigonometric expressions due to shift pi over 2. In right angle triangle, we subtract because that's the way we solve it, right, for the right angle triangle. But when we talk about angles on a unit circle or on the coordinate axis, when we move clockwise for positive direction, and remember, for example, if your terminal arm is in first quadrant, remember cast rule. In first quadrant, every trigonometric function is positive. In second, only sine is positive. Then in third, tangent is positive. In fourth, only cosine is positive. Which means, for example, if you want to set equivalent angle to one that is in first quadrant, for example, cosine in first quadrant, and you need to set a sine with respect to it, the only quadrant where you can look for equivalent solution is going to be second one. And it's going to be exactly pi over 2 offset, because that's how sine and cosine functions are basically related. Pi over 2 shift. Let's try solving this. Use equivalent trigonometric expressions to avoid the following to 4 decimal places, giving that sine pi over 2 equals 0 times 5, 8, 7, 8. Okay. Okay. So let's take a look at it. Sine pi over 5. Let's sketch a unit circle real quick and take a look. Pi over 2. Oh, pi over 5. Pi over 5 is somewhere here. It's in the first quadrant, right? This is our pi over 5. And we're looking into sine value in pi over 5. And there is a cosine 3 pi over 10. So basically, 3 pi over 10 is going to be 3 pi over 10. Pi over 5 is 36 degrees, I believe. Yeah, because pi over 5. Mm, okay, I'm a little confused how they want us to solve this in this particular example. Like, let's keep this example for later. For now, I'm sorry, guys. I don't really understand what particular approach do they want us to use. Okay, let's move on to the next slide. Let's see. Oh. Hmm. Just give me a second. Well, okay, let's try one more time. As you found out, for example, if we have sine pi over 5, it's going to be equivalent to cosine of pi over 2 minus pi over 5. In brackets, in order to perform this operation, we multiply this by 2 and this by 5 in order to bring the common denominator. Then cosine 5 pi over 10 subtract 2 pi over 10 would give us 3 cosine of 3 pi over 10. Oh, you see? Now we used equivalent trigonometric expressions and we showed that sine pi over 5 is equal to cosine of 3 pi over 10, as it says here. You see? So I just use the formula where sine x equals cosine pi over 2 minus x, as we found out from right angle triangle, remember? Is it clear now why cosine 3 pi over 10 equal to sine pi over 5? And now, as we know sine value to the 4 decimal places, we can tell for sure that cosine 3 pi over 10 is also 0.5878. And when we talk about cosine 7 pi over 10, what I want you to notice here, basically, 7 pi over 10. So it's 4 pi over 10 more, or 2 pi over 5. Okay, let's try another way around for b. What if we say that cosine 7 pi over 10 equals to sine 7 pi, oh no, to sine pi over 2 minus 7 pi over 10, okay? Now this times 5, which gives me sine 5 pi over 10 minus 7 pi over 10, which leaves me with sine minus 2 pi over 10, right? And now I can factor out 2 and 10, leave 5 here, right? Which is equal to sine of minus pi over 5. So basically the sine value, but in negative direction, counterclockwise, right? And we know that if we go positive direction, we're going to get positive y value, but for sine. And if we go in negative direction by the same degree, we're going to get negative value for sine function. So sine, I should say that sine of negative pi over 5 equals to minus sine of pi over 5, which is equal to negative 0.5878, and this is equal to cosine of 7 pi over 10. Is it clear? Guys, this is a very important part. I just showed you equivalent conversion from sine function to cosine, and other way around from cosine to sine function. Is there any questions at all about this part? Please, Safa, Hala, Muhammad, Mo, Mubashir, tell me. No questions. Great. In a bit, we're gonna move to your self personal work, and oh, sorry. Let me start sharing again. So, and finally, let's see. this. Given that cos secant 2 pi over 7 equals to 1 point something, use an equivalent trigonometric expression to determine secant. Okay. And for cos secant and secant, we have exactly the same ratio for equivalent, for identical functions. So basically, you have to do exactly the same thing. Now you should see it. Safa. Is it okay now? Okay, thank you. So cos secant of 2 pi over 7 equals to secant of pi over 2 minus this angle, which we call it x, minus 2 pi over 7. So what I should do in order to calculate this in radians, this part I multiply by 7, this part I multiply by 2, in order to bring to common denominator. Now secant of 7 pi over 14 minus 4 pi over 14 equals to secant of 3 pi over 14. And that's exactly what we are looking for, secant of 3 pi over 14. Now I can make a conclusion, then cos secant of 2 pi over 7 equals to secant of 3 pi over 14 after performing this equivalent transformation. And it's all together equal to 1.2790. Is that clear, guys? So now you remember, in order to convert sine to cosine, you have to write pi over 2 minus x for whatever function. It's equal to for both transformations, from sine to cosine and from cosine to sine. Okay? And now we're gonna move on to your work. We're gonna implement what we just covered in our lecture part of this class. Right here. Please take a look at the screen now. And we're gonna talk about equivalent trigonometric expressions. Please note down this table for your convenience. This is what we just showed in class. Take a notice that for some of these functions, you can see that it brings out a minus in front of it. It's because it's related to quadrants, to cast rule, and how positive direction rotation and negative direction rotation affects the result. Keep this in mind, guys. This is a very important table for your reference. Example number 1. Let me split you in 2 groups. There's 5 of you. Okay, and let me see what can I do here. Okay, it seems like I cannot make any rooms. Wait, 3 pi over 10, 7 pi over... Yeah, we just did the same one. Wait. Yeah, we also did this one. Oh, here's the example that we haven't covered. Determine an exact value for angle A such that secant A equivalent to cosecant 3A. This is an interesting one. So it's going to be individual work for every one of you. And the first person to finish, please text in direct messages to me in chat. You can start now. Please write a complete explanation of what you were doing, okay? Of your reasoning. And then the first person to submit a right answer would copy it to the board through annotation tool, okay? You're gonna write on the desk for the rest of the class. Okay, take your time, and I'm waiting for your direct messages. Um, Safa, first of all, your first answer is in degrees, and it's not really convenient to use degrees in this particular case, right? I prefer if you express your answer in radians because one 113.938 degrees doesn't sound like a right answer to me at all. But if you ask if it's zero, hmm, definitely not, because second and cosecond functions are offset from each other. They're not they won't end up in the same spot because, for an instance, second is a reciprocal of sine function. Cosecond is reciprocal of cosine function. And both of those functions are going to be just different in the same position. If you substitute zero into this equation, you're gonna have a second of zero equals cosecond of zero. No. Hala, I couldn't read your answer. Please use the equivalent functions. Why you don't need to overthink it. Why would we learn equivalent trigonometric expressions if we don't use them? Look, second x equals cosecond pi over 2 minus x, or cosecond x plus pi over 2 equals second x. You use wherever you like. Let's use with minus. Second x equals cosecond pi over 2 minus x, right? So second a equals cosecond pi over 2 minus a. And we also know that this is equal to cosecond of 3a. So cosecond pi over 2 equals a, and cosecond of 3a. And this is pretty simple equation to solve. Please, we're gonna have a 10-minute break, 10 to 15 minutes break now. And meanwhile, think about this solution. And remember, in mathematics, this is my advice to you. First of all, always read the question. If you don't understand how to solve it, read the question again. And also remember, for example, in the class, we always stick to the same topic, right? I wouldn't ask you to solve problem that is not related to today's topic. This topic is equivalent expressions. So logically, you're supposed to use equivalent expressions in order to find the solution. Okay? And then in a test, when basically approach how to solve it is going to be given to you in the question itself. So please, guys, solve this. We already covered it, guys. Remember, we talked about it before that for most of the angles, you have to use pi over 2 minus a, or minus x. Pi over 2 minus x is equivalence for most of the trigonometric ratios. Sine x equals cosine pi over 2 minus x. Cosine x equals sine of pi over 2 minus x, right? Please take a screenshot or note down this table, because when I just opened this file, I told you, take a look at this table, copy it. It's pretty convenient to have it by your side. Copy this table right now within the next 15 minutes and give me an answer to this equation. What A is equal to? Okay, guys, we're back. Look at I hope you had enough time to copy down this table. What about solution for this question? Are you ready to give me an answer? Guys, any feedback? What about this? Do you know what A is equal to? Guys, are you back? Are you with me? Because I don't see any response. And this is really like 30-second solution. Do you need me to explain how to find A? Okay, as soon as I have already explained you first part of the solution, when we implement equivalent ratios, now we got to the point where we have cos second of pi over 2 minus a and cos second of 3a. Basically, same function on left and right hand side, and thus this part of it, angle, should be equal to, right? So my conclusion is that pi over 2 minus a equals to 3a. Now, I move a over the equality sign, so it was minus turns to plus. Gonna be pi over 2 equals 3a plus a. Now, next step for me to be to factor out 4, because 3a plus a is 4a. So I factor out 4, and I'm gonna get, so I divide left and right hand side by 4, so pi over 8 equals a. This is my answer. How you like that, guys? A equals pi over 8. Is that clear? So basically, when you have sine on one side of equality and sine on the other side of equality, in order for equality to be true, expression in the brackets or x must be equal. Is it clear now? Okay, guys, great. Okay, I'll stop sharing for now. I hope you copied the equivalent expression table. Let's move on to the next part, and we're also going to talk about another equivalences in trigonometric functions. This is very big and not the easiest part of it, but very most crucial, I would say. And in particular, we're going to talk about compound angle formulas. On your screen, you can see how we can break single sine function into combination of sine and cosine functions. There is one core ratio that is being used to prove all of these relationships. But for now, we're just going to write it down, and it's going to be cosine squared x plus sine squared x equals 1. So basically, sum of squares of cosine and sine function of the same angle would always give you 1. Okay? Just remember this. Or doesn't matter whether it's sine comes first or cosine, but cosine squared plus sine squared of the same angle equals to 1. Also, sine of x plus x equals to sine 2x. Important to remember as well. And now let's take a look at the compound angle identities. Is a trigonometric expression that depends on two or more angles is known as compound angle identities. For sine function, when you want to express it, well, so usually it's not really convenient to have sum of two angles, or sometimes it's convenient to use compound angle identities for calculations. So sine x plus y equals sine x cosine y. Remember this, x for sine, cosine for y, plus s in brackets, then cosine x plus sine y. So first sine comes with x, then cosine comes with x. Then cosine comes with y, then sine comes with y. Same for minus, same sine x cosine y minus cosine x sine y. But now because we have minus in the brackets, we also have minus in between those. Please, while I'm explaining this, copy this down, because this you should know by heart. You just need to learn this. Cosine x plus y equals cosine x times cosine y. This is how is a compound angle identities for cosine function. Cosine x plus y equals cosine x cosine y minus sine x sine y. So how I remember it is that for sine function, it comes sine x times cosine y, and for cosine function, it's cosine times cosine and sine times sine. That's how I remember it. For cosine, two multiples of the same function, and for sine is a cross product of, for example, sine times cosine and cosine times sine. But another thing to remember about cosine, when we have plus in brackets, we're going to have minus in compound angle identity. If we have minus, we're going to have plus. Is that clear? Double angle identities. Also very important part of it. This is how you can express, for an instance, let's say you have sine of 2 pi over, I don't know, 3. Basically, sine of 2 pi over 3 is same as sine of pi over 3 plus pi over 3, right? Two double angle. P over 3, pi over 3 is double, 2 times. And this would be equal to 2 times sine pi over 3 times cosine of pi over 3, as it shows here. Also, note this down and memorize it. Then, cosine, for cosine function, double angle is different. Cosine of 2x would be equal to cosine squared x minus sine squared x. Just as formula here, when sum of those squared functions equals to 1. But now difference of them would be equal to cosine 2x. In this case, order is important. Cosine comes first and sine comes second, because we subtract. When we add, like here, order doesn't matter. Is there any questions? Another way for double angle identities of cosine. Cosine 2x equals 1 minus 2 sine squared x. And another one, cosine x equals 2 cosine squared x minus 1. How do we prove this? Fairly easily. We can use these two formulas in order to prove the one on the right hand side. And let me show you. For example, here, cosine 2x equals cosine squared x minus sine squared x. Now we use this basic formula and let's substitute sine 2x. From here, I'm going to use the green color to highlight it. From here, what we want to take? We want to take that sine squared x equals 1 minus cosine squared x, right? Sine squared x equals 1 minus cosine squared x. Now, I can substitute this into my formula here, and I'm going to get cosine squared x minus what is in the brackets, 1 minus cosine squared x. And when we open brackets, cosine 2x minus 1 plus cosine 2x, which is equals to 2 cosine squared x minus 1. You see? Guys, can you see that? Basically, I proved using one of the core identities, I proved that cosine 2x equals cosine squared x minus sine squared x could be also expressed as follows. Cosine of double angle equals 2 times cosine squared x minus 1. Same would be for this expression, but I would substitute cosine squared x instead. You can do that on your own at home. This is going to be as your practice. But for now, could you please copy down this table and let me know once you've finished, because this is so important for you to have in your notes. Okay? Did you understand the task? Copy this down and let me know once you're finished. Everyone say done in the chat so I can move on. Without this, I'm not moving on. Okay, 2 of you are done. Let's wait for the rest of the group. Okay, I can see Hala, Mohammed, Mubashir, Safa done. What about Mo and Ahmad? Mo, are you with us? Mo? Okay, let's move on. Mo is not responding. So let's apply a compound angle formula to determine the following cosine. Remember that, first of all, for cosine, if we have minus here, it's going to be plus in the formula. Is that correct? Cosine minus, we have plus in the formula. Great. So using the compound angle formula, we're going to get cosine of x, so 3 pi over 4 times cosine of y, which is pi over 6, plus sine of x, which is 3 pi over 4, times sine of y, which is pi over 6. Correct? Next step, each one of these angles we need to evaluate. 3 pi over 4. 3 pi over 4. How can we evaluate it, guys? So cosine pi over 6, it's 30 degrees. So 30 degrees, and 3 pi over 4. How many degrees is that? 3 pi over 4. If pi over 4 is 45 degrees, then 3 pi over 4 would be 135 degrees. So basically, on the unit circle, pi over 4 is here. Then this is 2 pi over 4, or pi over 2. And then here would be 3 pi over 4. And what is the value of cosine function and sine function of 3 pi over 4? It's basically the same 45-degree angle, right? For for 45-degree angle, do you remember? It's based on the right angle triangle. We have 1 square root of 2. So sine of 45 degrees equals to cosine of 45 degrees and equals to 1 over square root of 2, right? But let's look into quadrant. Where is it located? Cosine in first quadrant is positive as well as sine, but in second quadrant, according to cast rule, only sine is positive. So what am I going to get here for 3 pi over 4? Cosine is going to be negative, so minus 1 over square root of 2 times cosine pi over 6, cosine of 30 degrees. Does anybody remember cosine of 30 degrees? Cosine of 30 degrees is how much? Any suggestions? Do you remember the table? Cosine of 30 degrees would be square root of 3 over 2. Cosine of 30 degrees. Now plus sine 3 pi over 4. Sine is positive in this quadrant, so it's going to be 1 over square root of 2. Right? Times sine of 30 degrees, and sine of 30 degrees is 1 over 2. Now, calculate it. Here, so basically what we're going to get? We're going to get negative square root of 3 over 2 square root of 2 plus 1 over 2 square root of 2. Basically, negative here, so we can rewrite it as 1 minus square root of 3 divided by 2 and square root of 2. Let me check one thing. Oh, yeah, sorry. Yeah. Yeah, I cannot return the notes that I just made. I'm not sure if you got enough time to write it, but let's do it again and you write with me if you haven't copied it down. So I'm gonna write quick now. Cosine 3 pi over 4 cosine pi over 6. Please make sure to copy this down. I'm writing this for you. Sine of 3 pi over 4 times sine of pi over 6 equals to minus square root of 3 over 2 times 1 over square root of 2 plus wait. Oh, sorry. No. Yeah. Square root of 3 over 2 times 1 over square root of 2 Oh, wait. So yeah, cosine of 3 pi over 4 is minus square root of 2 over 2, because it's in second quadrant. Cosine of pi over 6 is square root of 3 over 2 plus sine of 3 pi over 4 is going to be in 45 degrees, and it's positive, so square root of 2 over 2 times sine pi over 6. Yep. Let me enlarge it like this. Yep. Times the sine of pi over 6 is 1 over 2. And here, square root of 2 over 2, we can factorize the square root of 2 times square root of 2 in denominator. So we can simplify it to get 1 over square root of 2. Same as here, it's going to be 1 over square root of 2. This is equals to negative square root of 3 over 2 square root of 2 plus 1 over 2 square root of 2, which is equals to 1 minus square root of 3 over 2 square root of 2. This is your final answer. Remember, we used the reasoning about that 3 pi over 4 is basically a multiple of pi over 4. And on the unit circle, such an angle would be positioned in second quadrant, right? This is pi over 4. This is 2 pi over 4. And this is 3 pi over 4. Also, we can treat it as 45-degree angle. Or what else you could do? You could say that cosine of 3 pi over 4 equals to sine of pi over 2 minus 3 pi over 4. And you're going to get negative sine of pi over 4, which is easy to solve. That's why you need to know equivalent trigonometric expressions. Because, for example, using unit circle would not be always convenient. In this particular case, it would be easier for you to convert cosine 3 pi over 4 to sine function, because you see sine of pi over 4 is well known. It's sine of 45-degree angle with minus. Please copy down this solution and let me know once you're done. Guys, any progress? Did you copy down this solution? Any questions about how I do this? Guys, please let me know if you're copying this down so we have only 10 minutes left and I still want to show you one more example. Okay, guys. I cannot wait any longer. Mubashir, Hala, thank you for your feedback. Use an appropriate compound angle formula to determine an exact value for a sine of pi over 12. Okay, let's take a look. Compound angle, what can we use here? Pi, sine pi over 12. Which formula can we use? Sine pi over 12. Sine pi over 12. Let's see. There is a mistake in this question. It's not pi over 12. It's supposed to be 11 pi over 12. Okay. That's what I figured out because it's pretty weird. So 11 pi over 12. So then we need to use appropriate compound angle formula to determine an exact value. So we know there are several special angles that we can evaluate, like pi over 4, pi over 2, etc. And now we need to express 11 pi over 12 as a combination of two special angles, right? Any ideas what two angles can we use for 11 pi over 12? I would suggest using such angles as pi over 4 and pi over 3, because both of 4 and 3 are factors of 12, right? For example, we can use, and it's 11 on top. How can we get 11? 11 is a sum of 6 and 5. It's an odd number, not really convenient, but we could use 8 and 3, right? 8 plus 3 is going to be 11. So what if so this is supposed to be 2, for an instance, and this is 1. Let me double check. Yes, great. I figured out it right. Wait. Where is here? Okay, I hope you can see my screen again now. So why I chose pi over 4 and 2 pi over 3? First of all, because denominators are pi over 4 and 2 pi over 3, because 4 and 3 are factors of 12, and those are special angles that we can use, right? Pi over 4 is 45 degrees, pi over 3 is 60 degrees, right? So why I choose 2 pi over 3? Because in order to get 11 pi, I need to somehow express the sum of these two special angles, right? Because I want to use compound angle formula. And pi over 4 plus 2 pi over 3, I can express this times 4, this times 3. In order to get common denominator, it's going to be 3 pi over 12 plus 8 pi over 12, right? Together it gives me 11 pi over 12. Great, so I can use that. Knowing that, let's use the compound formula in order to evaluate the sine function. Compound formula for sine, remember, if it's plus in the brackets, it's going to be plus in the formula as well. Now, let's move to the first page and see. For sine x plus y, sine x times cosine y, cosine x times sine y. Great. So sine x would be sine pi over 4 times cosine y times 2 pi over 3 plus sine 2 pi over 3 times cosine x, which is pi over 4. Great. So now let's convert cosine 2 pi over 3 so we can evaluate it. It's multiple of pi over 3, but we also can write it as cosine 2 pi over 3 equals to sine of pi over 2 minus 2 pi over 3. And it's going to be this times 3, this times 2 for common denominator. So it's going to be sine of minus pi over 6, right? Because 3 pi over 6 minus 4 pi over 6 would give us negative pi over 6. And pi over 6 is 30-degree angle, but with minus, so it's counterclockwise, so negative sine of pi over 6. And we know that sine of pi over 6 is equal, sine of 30 degrees equals to 1 over 2. As soon as it's minus, it's negative 1 over 2. Now we can substitute it instead of cosine 2 pi over 3 in the formula. And now let's do the same thing for sine value. What is sine of 2 pi over 3? Sine of 2 pi over 3 equals cosine of pi over 2 minus 2 pi over 3 equals, again, same operations, we're going to get cosine of negative pi over 6. Cosine value is positive. Cosine value will be still positive, right? Because it's now going to be in fourth quadrant. And cosine of 30 degrees equals to square root of, cosine of 30 degrees cosine of 30 degrees equals to square root of 3 over 2. This is what we can substitute instead of sine of 2 pi over 3. Now, finally, let's solve it. Sine of pi over 4, so sine of 45 degrees. Square root is 1 over square root of 2 times cosine of 2 pi over 3 times negative 1 over 2 plus sine of 2 pi over 3 plus square root of 3, right? When we substitute square root of 3 over 2 times cosine of pi over 4, same for 45-degree angle, 1 over square root of 2. Equals to 1, negative 1 over 2 square root of 2 plus square root of 3, 2 square root of 2. So as a result, square root of 3 minus 1 over 2 square root of 2. This is an exact value for sine of pi over 12. Is there any questions on how did I do this? Please copy this down, and there's going to be an end of today's class. We made quite a good job today, and I hope now you understand better how to work with trigonometric functions. Please ask your questions right now. I strongly encourage you to do that. Okay, guys? Did you understand the solution for this one? Okay, guys, I appreciate your time. I hope you had a productive class with me today. And please, this topic is very important to remember because basically most of your assignments and exercises in the tasks for this unit are going to be based on what we covered in these past classes, right? We're almost done with trigonometric functions. And remember how to convert degrees to radians, how to write an equivalent expressions for cosine and psi functions, and appropriate compound angle formula and double angle formulas that we covered in today's class. Those are essentials for trigonometric functions. Thank you for attending today's class. Wish you a good weekend and see you in the next one. Have a good one. Bye-bye.